toppings. So if you just did grade 9, you should be in perfect shape. And if you just did grade 10, you should still be in pretty good shape. So let us go. We're going to read that question. Pizza Hut charges $12 for an extra large cheese pizza. Each topping costs $1.50 extra. Draw a graph to represent the cost as a relation of the number of toppings. So, what is our IV? What is our DV? He waited patiently and took a bite of his pupusa. It's called a pupusa. It's an El Salvadoran dish. Pardon me? The dependent is the toppings? But I'm relating the cost to the toppings. So what is it? Toppings are independent. Absolutely. And cost is there. So, 1, 2, 3, 4. That's more than enough. If I have no toppings on the pizza, how much does it cost? $12. And none of this arguing that a cheese is a topping, because it's not. If you don't put cheese on a pizza, you have bread. You do not have a pizza. No, tomato sauce is just red butter. You have bread without cheese. Cheese is what makes pizza pizza. It doesn't have to be mozzarella cheese. It can be any cheese you want. But without cheese, you don't have a pizza. You can have lots of different sauces on the pizza. For example, if you go to Panago, you can get a barbecue sauce on your pizza. You can get white sauce on your pizza. You can get pesto sauce on your pizza. Still pizza. Why? Because they put cheese on it. Pardon? Yep. Because that's all a pizza crust is. It's bread. All right. So there's my first dot. Open or closed? Closed, because if I put no toppings on except cheese, it's going to be $12. That exists, right? Great. My next dot is at what? 1 and what value? $13.50. Open or closed dot? Closed. Excellent. Where's the next one? 15. Where's the next one? 16.50. Right? Everyone agree? Okay. It's graph now, yes? IV was top. DV was cost. Everybody cool? All right. Now, the $1 million question based on what we just studied. Do I connect the line or not? No, of course not. Why? Pardon me? It's not continuous. Why is it not continuous, though? I can't get half a topping. I can put toppings on half a pizza, but I cannot get half a topping. Right? So if I try to enter input of half a topping, I cannot have an output. Therefore, I cannot connect the line. Does everybody understand that? This is discrete data because no half toppings. Does everybody understand? Sweet. Okay, now, this is what we call a linear relation. I lie. It's actually a linear function. And what a linear function means is that any change to, I'm going to change that too. Any repeated, it'll catch up. Any repeated change to the IV results in a repeated change, it'll show up. Oh, wow. That's a really bad one. That's full on. It'll show up. Relax, brother. I'm going to have a bite of pupusa while we wait. Pupusa. Cheese. Hot sauce. Pork. Have you got what? Mm-hmm. And? If you did what to a baguette?
Just put a cheese string on it.
Is that cheese?
Yeah.
Is it on bread?
Yeah.
So it's pizza. Is it a good pizza? No. Also, they have to be cooked. Wow. This is really effed up. I'm going to get my whole pupusa finished. Huh? Do you know what I think has happened? No. I think in a repeated change to the DV. Now, what this means is this. When I moved this way, on the DV, how far, on the IV, how far was that? 1. How far up did I go? 1.5, right? Then, when I moved this way, how far did I go? 1. How far up? 1.5. This way, how far? So why would you do it to somebody else? Grow up. There's a very simple lesson all of you need to learn. If you don't want somebody doing it to you, don't do it to anyone else. It will fix every problem in your people's lives. I'm being cyberbullied. Don't talk to other people. Somebody's calling me a name. Walk away from them. It's not hard. Don't do crap to people that you don't want to have happen to you. Now, as I was saying before we were interrupted, when I went over here 1, how far up did I go? 1.5. Now you will notice every change in the IV of 1 got me a change in the DV of 1.5, making this pattern. And see how it repeats. That is what makes it a linear relation. It is not the fact that it makes a line. Because the line can only be there if the data is continuous. So you can still be a linear relation even if you don't draw the line. Does everyone understand that? I make a huge deal out of that every time I teach this. And when I do the test, every time I do it, I have a question that has discrete data, so there's no line. And every kid says, that's not a linear equation, there's no line. Every kid. Are you going to be the class that actually listens and understands? There will be no line, it's still a linear relation. Linear relations can be written in 4 ways. One of them is words. That's one way to write a linear relation. The second way to write a linear relation is as a table of values. Some of you have teachers that call the table of values a T-chart. Whatever you call it, I don't care. It's this, where you have the IV and the DV. Now, in grade 9, that was always X and Y, right? But in the world, you give those names. Always. And you can write it as an equation. The equation is the part that interests me right now. So let's go over here and let's fill in our table of values. When I have 0 toppings, what was my DV? $12. When I have 1 topping, do I still pay $12? Yeah. Plus how much? $1.50. Correct? When I have 2 toppings, do I still pay that first $12? Yep. And now I am paying how many 150s? 2 times 150. When I have 3 toppings, what do I pay? 12 plus 3 150s. What if when I have T toppings? 12 plus T times 150. So that gives us an equation. Cost equals 12 plus 150 times T. And the only reason I changed this order is because the 150 is a coefficient. Is everybody good? Yeah? Yeah, excellent. Now, I want to make sure of something. Actually, no, we'll do that on the next page. Linear relations. Okay? 4 ways. They are all the same. And they result, not resettle, result in a graph with constant changes to the IV and DV. If you need it drawn again, it looks like this. X, Y are always the same amount. Is everybody good? Going once. Going twice. Going thrice. Awesome. Turn the page over. Is this linear? How do you know? When this goes up by 5, this goes up by 9. When that goes up by 5, this goes up by 9. When that goes up by 5, that goes up by 9. So it is linear. Right? Everybody understand? Okay. This one. That side's going up by 5. That's repeating. Right? 5, 5, 5. What about this side? No. 75, then 2,925. So that is non-linear. Now, I want to take a moment and discuss how we turn this into an equation. Okay? So, I'm going up by 9, correct? Plus 9, plus 9, plus 9. This is the dependent variable, right? So the plus 9, plus 9, plus 9 must be happening to the independent variable, right? Everyone agree? Now, is there a shortcut in math to writing plus 9, plus 9, plus 9? What is it? No, that would be times, times, times. What's the shortcut to addition? Multiplication. That 9, 9, 9, that would be 9, right? Repeated over and over. So this 9 must multiply by the IV. So I'm going to call the IV C and the DV F. So 9C equals F so far, right? Now let's check. What is 9 times 0? 0. But this has to be 32, doesn't it? So what would I have to do to 9C to get to 32? I'd have to add 32. So now I'm building my equation. 9C plus 32 equals F, correct? Right? Well, now let's check the next one. What's 9 times 5? 45. 45 plus 32 is not 41, is it? Damn, son. Okay. Why would this change? Well, 9C, the F's are going up by 9s. What are the C's going up by? 5. Well, if this affected the independent variable, what does this affect? The dependent variable. So now I have 9C plus 32 equals 5F. Let's check. Does that work? 9 times 0 is 0. 0 plus 32 is 32. That's not 5F. Doesn't work, does it? So what do I need to do to fix this up? What should I be counting by? 5s, 9s, 1s, 7s? What should I be counting by? 1s. How do I make this 1? Divide by 5, right? Everybody cool? So if that divides by 5, what do you think that's got to divide by? So now let's check. Now I've got 9/5 C plus 32 equals F. When C is 0, 9/5 times 0 plus 32, is that 32? Yep. When C is 5, the 5s are going to cancel, right? So 9 is left over. Is 9 plus 2 41? Yep. What's going to happen with the 10s? 10 and 5 are going to cancel, yes? Which is going to 10 divided by 5 is 2. What's 2 times 9? 18. Is 18 plus 32 50? There's my equation. The changes here, multiply the IV. The changes here, multiply the DV. And then we got to get the DV as a unit. We'll do a little bit more practice with that, but it's not incredibly important to grade 10. It's very important to grade 11. So I'm making sure you see it. All right? All right. How do you know if that's going to be linear or not? Some of you already know. But if you don't, what can you do to that to see if it's going to be linear? Put a few numbers in. X, Y. What numbers should I put in? Easy ones. What are some easy numbers I could put in? 1, 2, 3. Do they go in for X or Y? Why do they go in for X? Because X is our input. 1, 2, 3. What's 2 times 1? Plus 4? 6. What's 2 times 2? Plus 4? What's 2 times 3? Plus 4? 10. Goes up by 1, goes up by 2. Linear or not? Linear. What about this one? What should I do? Same thing. 1, 2, 3. What's 1 squared? Times 4? Minus 1? 3. What's 2 squared? 4 times 4? Minus 1? 15. What's 3 squared? Times 4? Minus 1? 35. Linear? 1, 1, 12, 20. Non-linear. Man, there's a thief out there stealing someone's car. I do that when I go to Walmart and the alarm goes off. You guys know that? You know, when people walk out and the alarm goes off, even if they're not stealing anything? I always yell thief. I know, I am horrible. And now my son does it too. He doesn't do it now because he realizes that it's not very nice to do, but when he was a little kid, he's like 2, thief! And then one day it happened to me, and you know what my kid did? Thief! But he was like 13 when he did it, so it was even funnier. He doesn't do it to other people, it does it to me. What about that one? Linear? Looks linear. Let's check. When I go out 1, I go down 1.5, right? Out 1, down 1.5. Linear. What about this one? Is it the same? Is it linear? When I go over 1, how far up did I go? Nothing. I go over 1 again. How far up do I go? Nothing. I go over 1. How far up do I go? Nothing. Does it repeat? So, is it linear? Yeah, sure. You betcha. Oh, I forgot to point something out. What's different between B and C? The exponent. An exponent automatically means it's nonlinear. F. It's a tricky one. No, because it's curved. What about that one? And then the last thing we're going to do is we are going to make 2 tables of values and we're going to graph them. I'm going to shrink this down so it all fits on the screen. Now, this is something that you're going to, hopefully this fools none of you. But I have found over the past few years, when I make a table of values, I do this. I go X, Y, and I always go -2, -1, 0, 1, 2. And my students used to understand this. But over the last couple of years, they've started saying, how did you know to put in -2, -1, 0, 1, and 2? And I calmly say, what do you mean by how did I know what to put there? And they say, well, how do you know? You can put anything there. And, well, yeah, you can put anything there. And they get mad at me. X is the independent variable, yes? X is the input, yes? Input is what you do to something. So I can put any numbers there I want. Then the kids get angry and they're like, ugh. I hope that will be none of you. So what are my results? -2 times 2 is -4 plus 4 is 0. -1 times 2 is -2 plus 4 is 2. 0 plus 4 is 4. I'm screwing that up. -4 plus 4 is 0. -2 plus 4 is 2. Yeah, 0 plus is 4. 1 is 2 plus 4 is 6. 4 plus 4 is 8. Is it linear? Of course it is. We already know it's linear because there's no exponents. How do we graph it? -2, 0. -1, 2. 0, 4. 1, 6. 2, 8. Do I connect the line? Is this continuous or discrete data? It's continuous because can we put any number in for x? Even a fraction. Can I double it? Yeah. Can I then add 4? Yeah. So we draw the line. This one, same thing. -2, -1, 0, 1, 2. What's -2 squared? What's 4 minus 3? 1. What's -1 squared? What's 1 minus 3? -2. What's 0 squared? Minus 3, negative 3. What's 1 squared? 1 minus 3, negative 2. What's 2 squared? Minus 3, 1. Graph it. Negative 2, positive 1. Negative 1, negative 2. 0, negative 3. Then I get the same points over here. And it makes this sassy curve. And those sassy curves are called parabolas. I am only showing you them because they are a big part of grade 11. So I want you to see how you do them, because you can do them the exact same way as you do a line. Does anybody have a problem with that? Remember, the only thing that you care about over here is this makes a curvy line. It is not a linear relation. That is the grade 10 part of this. Is everybody good? Going once. Going twice. Going thrice. Lovely. Break is in 35 minutes. I want you to work on page 168 and 169 and 170. Listen to me, please, because this is very bothersome to me. Listen up. If the question says to sketch a graph, do you need to get out your ruler and make perfect graph paper? No. If you have graph paper, you're welcome to use it. Otherwise, just sketch it. So, for example, you have a point at 2, 7, and 3, 9, 4. What's the next point going to be? 11, thank you. You would graph it, okay, 1, 2, 3, 4, 9, 7, 8, 9, 10, 11, 2, 7, 3, 9, 4, 11, and just label one of the points, and I will know what you are doing. Does everyone understand? You needn't make it perfect. Okay? Now, obviously this one page, which even though it covers 3 pages in your book, it's because there's so many pictures in it, right? Obviously this is not going to take 35 minutes. Right? Start working on it now. I'll finish marking the cumulative. We'll go over the cumulative, and that should take us right to our break. Okay? Okay. Go.